Then next, RC transients. For series RC circuit, we have to understand the how transients in series RC circuit. So by taking one example, we have to understand the RC circuit transient analysis. Okay, voltage across the capacitor, how the voltage across the capacitor changes during transient condition and steady state condition. By taking one example, you can understand. So for example, this is the circuit. Okay, so in this example, the switch S as shown in figure is kept for a long time. And then it is closed at t is equal to 0. So find first one VC of 0 minus. So VC of 0 minus means we before switching actions. And similarly VC of 0 plus. And IC of 0 minus. IC of 0 plus and dVC of t by d. Okay. And then finally VC of infinity. So we have to verify these results by using PSpice. So before going to the results, first we have to analyze theoretically. So what is the voltage across the capacitor? So VC of 0 minus. So what is the meaning of the switch? At t is equal to 0, switch is closed. T less than 0, switch is open. At t is equal to 0, the switch is moving downwards direction. That means at t is equal to 0, switch is closed. At t less than 0, switch is open condition. So under open condition is also the circuit is under steady state. So resistor I connected in series with the capacitor across the voltage source. It's connected, R and C are connected series and is across the 40 voltage source. So RC is under steady state before switching action. That is nothing but t less than 0. R and C are series. That means so capacitor is fully charged under this steady state condition before switching action. Understood? So fully charged means what is the voltage across the capacitor is nothing but 40 volts source voltage. So as we know that the voltage across the capacitor VC cannot change instantaneously. So due to principle of conservation of charge. So voltage across the capacitor does not allow the sudden changes in voltage. So capacitor does not allow sudden changes in voltage because of principle of conservation of charge. Therefore, the voltage across the capacitor just before the switch is closed. So that is nothing but before switching action, VC of 0 minus is equal to the VC of 0 minus plus. So the voltage across the capacitor just after the switch is closed, VC of 0 plus that is equal to 40 volts. So with 40 volts because of under steady state condition before switching action, the capacitor is called under steady state condition. That's why the whatever the voltage supplied by the source is fully charged. So that's why VC of 0 minus is equal to VC of 0 plus. The voltage across the capacitor is called 40 volts. So, and next, it may be noted that the capacitor current before the switch is closed. So here before switching action means capacitor is fully charged. So what is the meaning of this called capacitor actually is open circuit? That's why current flowing to the circuit IC of 0 minus is equal to 0. So current flowing to the 10 ohm resistor is equal to 0. The voltage drop across the 10 ohm resistor is equal to 0. So what is the voltage drop present across the source and also same voltage present across the capacitor. So that's why, so potential difference between these two. So for voltage source and capacitor is equal to 0. That's why current 0. So the current IC of 0 minus is equal to 0. On the other hand, at t is equal to 0, the current 10 ohm resistor is 0. Current flowing to the 10 ohm resistor is 0, but current through the capacitor can be computed as IC of 0 plus is equal to VC of 0 by 6. Okay, VC of 0 by 6. So like this. If it is after switching action, it is closed. So what is the voltage across the capacitor? It's called 40 volts just after switching action. So then 40 by 6 is called current flowing to the capacitor. Okay, IC of 0 plus, that is called just after switching action. Just after switching action means just closing the switching and then voltage across the capacitor is called 40 voltage source. This actually is a source and is connected parallel. No? So that's why current is nothing but, so IC of 0 plus is equal to VC of 0 by 6, then 40 by 6, that is equal to 6.66 amps. So note voltage across the capacitor cannot change instantaneously at instant of switching. In this instant of switching, capacitor does not allow sudden changes in voltage. That's why 40 voltage. The rate of change of capacitor voltage at a time C into dV by dt, Vc of t by dt, that is equal to, so IC of 0 by C, that is equal to 6.66 divided by T, 4, 1.665 volts. Okay, and the time constant before switch was closed at tau is equal to RC, that is equal to 10 into 4, so 40 seconds. And time constant after the circuit switch was closed, time is equal to RTH into C, that is equal to 15 seconds. So here 40 seconds before the switch was closed. Here 15 seconds after the switch was closed. Okay, and next replace the part of the circuit, then contain only independent sources and resistive elements by an equivalent theorem, equivalent Thevenin's voltage source. In this case, we need to only find the Thevenin's resistance RTH. Okay, so in the circuit, when the switch is kept in closed position, when the switch is kept at closed position, and initially capacitor will be charged to discharge the state, and subsequently its voltage decreases with increasing time. Finally, the steady state capacitor is charged to voltage of, so Vc of t is equal to infinity is nothing but 14 to 6 by 10 plus 6, that is equal to 15 volts. Okay, so this is the voltage across the capacitor at t is equal to infinity. Theoretically, time required to reach the capacitor to steady state is called 5 time constant, that is equal to 75 seconds. Okay, so this experiment first we have to execute by using PSpice. Go to PSpice schematic, and here what is the voltage source? One voltage source, and one resistor and capacitor. So take element from the PSpice, VDC, place here VDC, and similarly a resistor, place here resistor, and then one capacitor. Okay, capacitor, so place here, and then next what is the switch close, this is called switch close switch. Select switch T close. Okay, place here, and then next one more resistor is required, so place resistor controller and connect like this. Just connect here, then after that we have to connect the switch. Here connect like this, and here to this circuit. Okay, and here change the value of voltage source is called 40 DC voltage is equal to 40. Oh, save alter, okay. And then here what is the resistance? 10 ohm resistance. Value of resistance is called 10. So, and then next capacitor is called 4 farads. 4 farads. And then next switch is closed at t is equal to 0. And then 6 ohm resistance. This is called 6 ohm. Value of resistance is called 6. Ohm resistance place here. And similarly, one take one ground, connect here, ground here, and zoom to fit. So go to analysis, setup, enable transient. Okay. So place like this. So before going to that, so what is the time constant of the circuit? So 40 seconds and 50 seconds. Take 40 seconds means take 50 seconds. Take 50 seconds. example, final time is called 50 seconds. Then okay, save RC transient. RC transient. Save like this. And then so voltage across the capacitor, first we have to identify. Take one voltage markers voltage difference. Here this is called voltage. Connect like this. So before switching action, at t less than 0, switch is open. Okay, t less than 0, switch is under open condition. T greater than 0, only the switch is closed. T less than 0, switch is open. T greater than 0, switch is closed. That means Vc of 0 minus is called voltage across the capacitor is nothing but 40 volts. So simulate, and then we will get voltage across the capacitor is called 40 volts. Okay, here 40 volts onwards, so this voltage across the capacitor changes. Okay, here 40. So I can easily understand it. So 40, from 40 onwards, the voltage across the capacitor changes. So if the final time is called 50 seconds. So if less than 50 seconds, then how the voltage across the capacitor changes means we have to understand. So go to analysis, setup, change final time to, for example, 5 seconds. Then okay, close. Then simulate like this. Change this. So finally, the voltage across the capacitor is changing from 42. So like this. In this way, the voltage across the capacitor is decreasing. Okay. So from this waveform, you can understand that. So here, this time. So what is the final voltage across the capacitor? So Vc at t is equal to infinity. So voltage across the capacitor is called 15 volts. So that's why this voltage is nothing but 15 volts. So steady state. So constant voltage across the capacitor under steady state condition, that is equal to 15 volts. By using this probe, you can understand this 15.016. So this is called voltage across the capacitor under steady state condition. And during transient condition, voltage across the t is equal to 0 seconds. The voltage across the capacitor is called 40 volts. So from 40 volts onwards, it's decreasing and it's settled at 15 volts. Okay. And also in this circuit, current at infinity condition. Current flow into the 6 ohm resistor under infinity condition is nothing but I6 of infinity is called. So this is called open circuit under steady state condition. The switch T is closed at T is equal to infinity, and then this is called open circuit, and then 40 divided by 10 plus 6. 40 by 16 is called 2.5. Approximately, we will get 2.5. 40 by 16 is called 2.5. So we have to connect one circuit here, and the circuit we have to connect one current source. Understood? Circuit, in this circuit, connect one current marker uh, across a 6 ohm resistor. So then current is nothing but 40 divided by 10 plus 6. 40 divided by 6 is called 2.5. So then simulate and then open window. So this is our waveform. So under steady state condition, current flow into the inductor is called enable toggle cursor like this. So this is called here current is called 2.49. So 2.5 amps. The current flow into the 6 ohm resistor finally is called 2.5 amps. So like this we have to verify results by using PSpice. Okay, this is about a transient analysis of series RC circuit.